In 1923, this man, named Edwin Hubble, pointed an optical device into the night sky. He saw this, the Andromeda Galaxy. He had succeeded in proving that there were galaxies outside of our own. This changed everything we thought we knew about space. The optical device he had used was this telescope. It is a reflecting telescope, which is one of two main types of telescopes. The origins of the telescope are unknown, though the earliest documented instance of the telescope was in 1608 when this man, Hans Lippershey, a glassmaker from Netherlands, applied for a patent on a device that magnified an object. In 1610, 300 years before Hubble and 1 year after Hans Lippershey, the infamous Italian astronomer Galileo Galilei had made his own telescope. This was the first instance of a completed refracting telescope. It had an 8 times magnification, which would later be improved to be 23 times. Galileo had used a set of concave lens along with a set of convex lens. The first lens, which is called the objective lens, consists of a converging lens that directs light towards one focal point. The second lens is the eyepiece. It collects all of the dispersed light and refracts them so that they are parallel to the principal axis. If the light rays are extrapolated beyond the objective lens, they will make the light source look bigger than it really is. Galileo used this property of light and lenses so that he can see celestial objects. He was able to see the moons of Jupiter as well as the rings of Saturn. Galileo's findings had upset the Church. The findings indicated that Earth was not at the center of the universe. This had contradicted the Church's teachings that the Earth was indeed at the center of the universe. Many improvements were made to Galileo's telescope over the years. Oftentimes, such improvements were simply increase in magnification or increase in clarity. The most notable improvement would have been made by physicist Isaac Newton. He had reshaped Galileo's telescopes by replacing lens with mirrors. Newton had applied the laws of spherical and chromatic aberration. Chromatic aberration is what causes the separation of blue and red light, and spherical aberration is the uneven refraction of light. These principles of aberration create images that are blurry and do not have definite colors, such as the one that is shown above. Chromatic aberration occurs due to the principle that colors with lower frequencies will refract at a lesser angle. This will cause the separation of colors in the white light. Spherical aberration occurs as light that is refracted at a less dense point of a lens will converge at a point that is closer to the lens. This causes light to converge at different points and create a blurry image. Isaac Newton saw that concave mirrors had the same concentrating ability as a concave lens. But the concave mirror did not have the properties of chromatic or spherical aberration the same way that a concave lens does. By utilizing the concentration ability of a concave mirror, Isaac Newton was able to create the first reflector telescope. The objective lens was replaced by an objective or primary mirror. This primary mirror played the same role that the objective lens had played in concentrating light into one focus point. The secondary mirror reflected the already reflected light into the eyes of a viewer. In 1668, 60 years after Hans Lippershey had applied for his patent, Sir Isaac Newton had finished the construction of his first reflecting telescope. Telescopes on Earth are beneath the Earth's atmosphere. As such, natural weather patterns such as cloud or dust can block light rays and distort the image that appears to the eye. Artificial light also acts as a pollutant in the image, overpowering the light from otherwise visible but dim stars. Even on a clear night away from artificial light, Earth's atmosphere can still act as a giant lens, refracting and distorting the image ever so slightly. Because light is traveling from a vacuum to another medium before entering the telescope, the principles of chromatic aberration are applied once again. This causes small amounts of distortion in the image created. This did not matter in the past, as we were only looking at objects that were relatively close, such as the ones that were in our solar system or the ones that are within our galaxy. But in the present day, such discrepancies can cause us to miss distant celestial objects. To combat this, astronomers have launched powerful telescopes into space. On April 24, 1990, the Hubble Space Telescope was launched. This telescope was a reflector telescope that could detect frequencies of infrared, ultraviolet, and visible light. There were numerous problems in the initial setup of the Hubble telescope in space. These stemmed from the imprecision of mirrors and other equipment, as well as outdated equipment. This led to 5 servicing missions to fix these mistakes. The last one was named Servicing Mission 4. This took place from May 11th to May 24th, 2009. The mission was to install the Cosmic Origin spectrograph as well as the Wide Field Camera 3. Despite troubles in its startup, it has made numerous accomplishments, such as pinning the age of the universe at 13.7 billion years old and seeing galaxies in the early universe. Hubble also discovered many moons orbiting Pluto. Today, the Hubble Space Telescope still holds the place for the most powerful telescope made by humans. It still captures mesmerizing images and creates beautiful maps, such as this one. The Hubble Space Telescope demonstrates the amazing ability possessed by humans to see, create, then improve. But improvements can always be made. Under this philosophy, many international space agencies have collaborated on the James Webb Telescope project. This telescope is scheduled to launch in March of 2021. It is a reflector telescope that is composed of 18 beryllium hexagons. It has a system that is 100 times more powerful than the one that the current Hubble telescope has. It has capabilities to detect infrared, ultraviolet, and visible light. Astronomers aim to use this telescope to see back to the beginning of the universe, such as the first galaxies and first stars. The telescope also aims to answer how black holes form, how galaxies merge, and maybe see life in other systems. Advances in powerful technology, such as the telescope, could answer questions that we have not even thought of yet. It is unknown when the next leap will be, but you might be a part of it.